Site survey, equipment, and procedures. Now in the previous video we learned about what type of information we should have in preparation for the physical site survey. Now that we have that information, it's time to actually conduct the physical site survey. So in order to conduct the physical site survey, we have to have the necessary equipment. So in order to perform an effective site survey, we'll need to have a baseline of equipment that can ideally be used in a lot of different circumstances, from a hospital to a university campus, to a retail store, to office buildings, to military location, to warehousing, etc. So in addition to a baseline of equipment, we also need to know the type of information we should be gathering while we're doing the physical site survey, both of which we're going to learn in this video. So let's put our site survey cap on and fasten our seatbelts because we're going to get started here. So first off, what equipment do we need in order to perform an effective site survey? So to learn about that, let's bring up another whiteboard. So this serves as a basic checklist or laundry list of the essential equipment that we need in order to perform an effective site survey. However, let's flesh this out and go into this list with a little more detail, starting with the wireless access points. And to do that, we'll bring up another whiteboard. Now first off, you should have at least 2 wireless access points and a bridge or a wireless access point that can run in bridge mode. And ideally, the wireless access point should be from the same vendor, and they should have the ability to vary their power output in order to configure different radio frequency cell sizes. Additionally, the wireless access points you use for the site survey should have a pigtail antenna connection in order to support external antennas. So you should bring along with you on the site survey indoor and outdoor antennas of different types, such as omnidirectional, patch antennas, Yagi antennas. You should bring along the appropriate mounts. For example, you should have a ceiling mount. You should have a mount for connecting the antenna to an indoor-outdoor stand, and all the related cables and connectors for connecting the access point to the antenna and the mounting equipment and the stands, etc. Also, you need to provide power to your wireless access point. Now, undoubtedly, you'll probably run into situations where you need to set up your wireless access point in a specific location only to find that there's no power outlets. There's no AC power outlet to connect that wireless access point in, so in those situations, it's great to have your own source of power. And there's several manufacturers that create battery packs explicitly for site surveys. So in this situation, what you can do is use a battery pack in conjunction with a converter. So you can use either a DC to AC converter or a power over Ethernet DC to AC converter, which is in turn connected to the actual battery pack. So this allows you, this gives you 2 things. Number 1, it gives you power, and number 2, it gives you mobility. So it gives you the mobility and the flexibility to place your wireless access point in locations that you need to place it in order to perform your test. These battery packs are rechargeable, and most good quality battery packs used for site surveys will usually have at least 8 hours of solid power to allow you to get through a good solid day of site surveying. Also, you're going to need something to carry all this stuff around in. And the best option for that is a hard shell plastic case, which is good not only for carrying all this equipment, but for shipping the equipment as well. These hard shell plastic cases should ideally have wheels on them, a handle, should have little mounting tabs where you can place a padlock on it, enough space where you can place some foam inside it as well to give you one-stop shopping for carrying almost all of your gear that you're going to use for your physical site survey. So to give you an idea of what I'm talking about here, I just happen to have a picture of such a case. Let me bring it up right now. So this is a very heavy-duty hard-shell plastic case, which, as you see here, has several handles. We've got wheels. We've got acoustic foam in here, which keeps everything in place and secure so it doesn't get all shaken up while it's being shipped. The ability to lock the lid of the case into place. So this is a classic example of a nice, good quality hard-shell plastic case that we can use for holding all the equipment that we need for our site survey. Now, moving forward here, in addition to the wireless access point and its accessories, you're also going to need some wireless network adapters. Now, there's a couple of points to bear in mind about this, so let's bring up another whiteboard and discuss this a little further here. First off, you should have at least 2 or more wireless adapters, so in case one goes bad, you've always got another one. Ideally, you should have a wireless adapter that has the ability to mount an external antenna and one without to get different readings. And also, and I can't stress this enough, the wireless adapter should come from the same vendor as the wireless access point. So, for example, if the wireless access point vendor is Cisco, the wireless network adapter should also be from Cisco. Now, oftentimes, just flaky functionality issues can be the result of having a mismatch of vendors for your wireless access points and your wireless network adapters. Now, you'll find that the most popular wireless LAN infrastructure devices in an enterprise environment are made from either Cisco, Proxima, Lucent, Symbol, even Intel, 3Com. I personally have had great success with Cisco devices and Orinoco Proxima devices. Either one of those vendors have always provided good, solid, consistent quality and good, solid, consistent connectivity as well for their wireless LAN infrastructure devices. And I've also had several situations where I was not able to establish wireless connectivity with other vendors' wireless network adapters. But as soon as I use a Cisco wireless network adapter or an Orinoco Proxima wireless network adapter, I've got connectivity in no time flat and excellent signal strength. So you want to spend the extra few dollars for getting a good quality wireless access point, good quality wireless network adapter from the same vendor. And oftentimes the vendor that you use for your own equipment, it will be the vendor that you use for the client's equipment as well. So it's good to have familiarity with the equipment, and it's also good to have experience knowing that this is good, solid, reliable equipment as well. Now, another benefit of getting good quality wireless network adapters is that oftentimes they come with utilities or applications that will help you to perform the site survey. So let's bring up another whiteboard and learn about the type of applications we're going to need for performing the site survey. Now, in order to position the wireless access point in its most effective location, you'll need to do a radio frequency sweep of the surrounding area to test for signal strength, noise, and signal-to-noise ratio, and optionally link speed as well. Now, signal strength, also known as signal level, is the strength of the wireless signal as received at the wireless client adapter, and it's important to know the signal strength level in order to help troubleshoot the wireless connectivity. So if you have very low signal strength, it's going to be hard to maintain wireless connectivity. In contrast, radio frequency noise levels are used to measure the level of radio frequency interference at the wireless client adapter. And we've talked about sources of interference which create noise, this background noise, such as cordless phones, microwave ovens, baby monitors, so on and so forth. Now, the signal-to-noise ratio measurement, or otherwise known as SNR, is a very, very important indicator, and this is used to diagnose wireless performance in general. The signal-to-noise ratio, or SNR, indicates the relative strength of the received signal compared to the local background noise level, such as the noise level generated, again, by cordless phones and the such. So the SNR measurement is a very, very good indicator as to the quality of the link between the transmitter and the receiver. And as a general rule of thumb, the higher the SNR measurement value, the better quality of radio link or wireless network connectivity that you're going to have between the wireless station and the wireless access point. And as a general rule of thumb, a measurement of 22 dB or higher is a very good signal-to-noise ratio measurement. Meaning if the SNR measurement at the wireless station is 22 dB or higher, it means that it'll typically have a good, stable, strong connectivity between the wireless station and the wireless access point. Now, in order to find sources of radio frequency interference, again, as we've learned in a previous video, we would use a spectrum analyzer. So the noise measurement just simply indicates the level of noise in the background. However, we use the spectrum analyzer to actually find the source of the noise to help us, again, to find the source and ideally eliminate the source, or at least try to work around the source by using the spectrum analyzer. Additionally, you should also have a protocol analyzer so you can use that to identify if there's any wireless LANs within the radio frequency coverage area of the proposed wireless LAN. And if so, you can use it to not only identify that yes, that there are wireless LAN or LANs within the coverage area, but also to determine which channels they are transmitting on and the signal strength of those wireless LANs to help you, again, determine the best placement for your wireless access points and or try to work around the interference that could be potentially created by these other wireless LANs, which you may not be able to control. It could be another business's wireless LAN. So typically, in order to get all these measurements, you're going to need to use multiple applications or multiple devices. Some radio frequency utility software allows you to determine all three of these measurements: signal strength, noise, signal-to-noise ratio. In some instances, you might have to use multiple applications to glean these measurements. Also, the spectrum analyzer and protocol analyzer are typically separate applications or separate devices. However, as of late, there are some companies that are offering all-in-one site survey applications that integrate all of this functionality into one application. And I have an example of one of these all-in-one site survey applications called Air Magnet Surveyor, which I have minimized down here in the taskbar. Let me bring it up and we'll take a look at it. So first off, on the right-hand side, we see a floor plan of an area that somebody has done a site survey of. That's a cool feature of this application, is that if you have the floor plan or the blueprint of the area that you need to do a site survey of already in a digital format, such as a JPEG or a GIF format, you can import that into this application. If you don't already have the floor plan or blueprint in a graphic format, you can get it into a graphic format simply by scanning it into your computer. And once you have that floor plan or blueprint into this application, then you can perform what's referred to as a passive survey, which will collect all radio frequency signals and noise in the radio frequency area regardless of source. So, for example, it's going to capture and collect information from baby monitors, microwave ovens, other wireless LANs, etc. You can also perform an active scan of the area, and this is used to connect to a specific access point in order to perform connectivity tests between the wireless station and that specific wireless access point. So in this particular example, we're reviewing the results of a passive scan, and we can view the different types of radio frequency information that was captured by going up to the top here. So right now we see the different signal strength measurements within this radio frequency area. Then we can also look at the background noise level, the signal-to-noise ratio, and interference levels. So again, whether you use one application or multiple applications, you should at the very minimum be able to find measurements for signal strength, noise level, signal-to-noise ratio, be able to identify where other wireless LANs are, and to be able to find the sources of radio frequency noise. Now, in order to walk around a facility and capture this radio frequency information using one of these applications or applications, you're going to need to run these applications either on a laptop or on a handheld device such as a personal digital assistant to give you the portability you need to walk around a facility. But there's a couple of things you should take into consideration as to whether or not you use a laptop or a PDA. Let's bring up a whiteboard and learn a little more about this. So again, you're going to need to use a mobile device such as a laptop or a PDA with a wireless network adapter so you can capture this radio frequency information. However, most laptops don't have enough battery power to be able to last at least 8 hours to perform a whole day's work of site surveying. So a couple of things to take into consideration is, number one, bring extra batteries. Number two, bring a battery charger. But oftentimes people are starting to use PDAs instead of laptops in order to conduct a site survey. Number one, the PDAs are much lighter than a laptop, and they have better battery duration. So the batteries can simply last longer on a PDA than they do with a laptop. But again, you should bring your battery charger for the PDA and bring some extra batteries for the PDA as well. And lastly, there's some miscellaneous things that you should bring along in a site survey as well, which are also very important. Let's bring up another whiteboard and take a look at this list of items. You'll need absolutely some paper, some pens, a clipboard to be able to write information on, Good old duct tape. Do not leave home without it. You can fix your house. You can fix cars. You can mount antennas to poles with duct tape. This is a universal tool. Do not leave home without duct tape. Plastic zip ties are great for also mounting antennas to poles, to helping to tie down wires. Double-sided Velcro tape is also good for temporarily mounting antennas, for mounting wireless access points. It's also a very, very good idea for having a measuring wheel to allow you to find the actual distance from one location to another, from one point to another rather. Also bring along a little toolkit. It's good to have some screwdrivers and the such with you. And another great thing to have is simply a digital camera as well. So as the saying goes, a picture is worth 1,000 words. It's always great to have pictures to refer back to of the site survey area, either indoors and outdoors. Have pictures of potential sources of interference, other buildings, other towers, trees, and the such. And last but not least, take off those dress shoes, take off those boots, and get a very, very comfortable set of shoes, because oftentimes you're going to end up doing a lot of walking when you're performing a site survey. So now that we've got all of our gear in place to actually conduct a site survey, the next step is to actually collect radio frequency information and to document that information. Let's bring up a whiteboard and learn about the key areas that we should document while we're performing a site survey. So remember that the site survey is serving as a map or as a guide to successfully implement a wireless LAN. So in order to create this map or this guide, we need to provide the client and the installer the information necessary to successfully implement the wireless LAN. So in order to do this, we need to collect information and document information from these key areas. So let's learn about these areas individually, first starting with RF coverage area, and to do that we're going to bring up another whiteboard. So first off, before we start collecting radio frequency information, we need to choose the appropriate antenna type for the area that we're going to collect radio frequency information from. So for example, if we're on a floor of an office building, it's just one big large room, probably be best to use an omnidirectional antenna and to place that access point and the antenna in the middle of the room. Now in contrast, if we're trying to get coverage area readings, radio frequency coverage area readings for a very long hallway, it would be best to use a semi-directional antenna such as a Yagi antenna or a patch antenna, and then place that antenna with the access point probably at the back of the room or at a corner of a room. Now this serves as a general guideline for the initial positioning of the antenna and the access point, but there's no real hard and fast right or wrong answer. The world is not going to implode if you initially place the access point and the antenna in the corner of a room versus the middle of the room. But the point being is you have to start somewhere, and you have to start taking readings from somewhere. And then once you have some initial readings, you want to marry those results with the client needs, and at that point you may find that you're going to need to move the access point and the antenna around a bit to change the coverage area to meet the coverage area requirements of the client. So once you place the wireless access point and its associated antenna in an initial location and fired it up and it's up and running and you've got power to your access point, then it's time to start up your laptop or your PDA and then run your site survey tools to collect radio frequency information that we've learned about, such as data rate, which is measured in megabits per second, and signal strength, which is measured in dBm, which stands for decibels relative to 1 milliwatt. The noise level, which again is measured in dBm, and then the signal to noise ratio, which is measured in dB, which stands for decibels. So once you've got some initial readings and everything's working well, you then want to take out your clipboard that has the floor plan or the blueprint of the area that you're conducting the site survey of, and then walk along slowly, and then pause about every 20 feet or so and jot down the readings for the area that you're now paused in. So for example, if you were to perform a site survey in a room that is a square shape, you might want to start off in a corner of a room and take some initial readings from that corner and document that information on the floor plan. So this could be the floor plan right here that you've got in your clipboard. So you say, in this corner, this bottom left-hand corner, these are the readings for data rate, signal strength, noise, SNR. Then you walk a little bit, take another reading, jot those down in the floor plan, walk a bit, take another reading, etc., etc. So by the end of your site survey, your floor plan or your blueprint is going to be have a lot of readings on it to give you an accurate picture of the radio frequency coverage area and sources of interference, and also to help you determine the data rate boundaries, which is exactly what we have on our next slide here. So while you're walking around and you're recording the data rates, you also want to find out the actual data rate boundaries, which are essentially spheres around your access point where the data rate drops automatically from one rate to another rate. So for example, if you're using 802.11g equipment, you want to find out where the data rate drops from 54 megabits to 48 megabits, and then to 36 megabits, and then to 24 megabits, etc. So as a result, you should end up with something like this on your floor plan, where you've got your access point here, and then you've got your first concentric zone, your little sphere around that. And that first sphere, or this boundary, is 54 megabits. And then your next sphere, or your data rate boundary, again is going to be the next level, or the next data rate that it automatically drops down to, which is 48. And you want to note the distance between these boundaries as well. Or rather, the distance from the access point to the actual data rate boundaries. Now, this is very important for roaming users and the placement of the wireless stations. They'll need to know, if I place my laptop here or my PDA here, what will the actual data rate be? So, for example, if I were to go to the conference room, what is the data rate in the conference room? So maybe the conference room has a data rate of 48 megabits per second, but if they go to the break room, then the data rate drops all the way down to 24 megabits per second. So again, you're going to need to carefully document your findings to see if they meet the goals of the client. So when you give the site survey to the client, they might come back and say, you know what, we really do need a data rate of 54 megabits in the conference room. So you might end up suggesting that they actually have a dedicated access point in the conference room as a result of their business goals and needs. Now, in addition to finding and document the data rate or the connection speed boundaries, it's also very important to know the actual throughput boundaries as well. What is the actual data transfer rate? So to learn about that, let's bring up another whiteboard. Now remember from our previous discussions that the actual throughput or data transfer rates are typically at least 50% less than the connection speed, which is due to the CSMA/CIA overhead. And so the mileage is going to vary quite a bit here. Even though a user might be connected at a speed of 54 megabits per second, the actual data transfer rates are going to be considerably lower. So it's best to inform the clients of this by doing file transfer tests from different locations in the area that you're performing a site survey of. So once you perform the test and then look back in the business goals for certain users, you might find that the users in the graphic department have to have a data transfer rate of, say for example, at least 20 megabits per second. So that might mean you're going to have to increase the number of access points to provide the users in the graphic department the data transfer rates that they need in order to perform their job. So again, in addition to providing the client information about the connection speed boundaries, they should also have some hard numbers to work with about the actual data transfer rates that they can expect in certain locations. Now, the data transfer rates can also be affected by interference as well. Let's bring up another whiteboard and discuss that. So in order to successfully implement a wireless LAN for the client, you're going to need to find and then document all sources of radio frequency interference. So the company might have a pre-existing wireless LAN. You're going to need to discover what channels those wireless LANs are and the coverage area of those wireless LANs. However, there could be some neighboring wireless LANs that can affect the wireless LAN that you want to set up and configure. So for example, maybe the company is located on a multi-tenant office building. They might be located on the second floor of the building. However, on the third floor, there could be a different company with their own pre-existing wireless LAN. And maybe on the first floor, there could be another company with their own wireless LAN as well. So we could have neighboring wireless LANs that could cause interference with the existing wireless LANs and the future wireless LANs that we want to set up and configure for the client. Now, in addition to neighboring wireless LANs, we also need to discover sources of interference for all radio frequency devices, not just wireless LANs, such as the cordless phones, such as microwave ovens. If we're in a hospital, you want to look for radiology equipment. In the nursery ward, there could be baby monitors, which could be causes of radio frequency interference. So once we find sources of radio frequency interference, we can try to work around those sources, try to eliminate those sources if those sources belong to the company that you want to implement the wireless LAN in. In a situation where neighboring companies have wireless LANs, we can try to work around it by using a non-overlapping channel for the wireless LAN that you want to implement for the company. Also, it's a good idea to see if there's any plans for future wireless LANs within your radio frequency coverage area. So maybe the neighboring companies don't have a wireless LAN right now, but they plan to implement one in the relatively near future. So maybe your company and the neighboring company can work out an agreement of using non-overlapping channels to provide mutual benefit for each other's wireless LANs. Now, obstacles aren't sources of radio frequency interference per se, but they can cause signal loss, which can sometimes have similar effects to interference. So some obstacles, depending on their consistency, can have quite an effect on the effective range of the radio frequency coverage. So we want to document any cubicles that are in the facility, metal blinds, firewalls, cement walls, metal mesh windows, which you often see in hospitals and educational facilities, and other types of obstacles which can cause signal loss as well, which as a result will decrease the effective range of the radio frequency coverage. So again, by finding sources of interference and by finding obstacles which can cause signal loss, provides us more information that we can use to either work around these sources of interference or work around these obstacles and still create a wireless LAN that meets the goals and the objectives of the client. Now, in addition to capturing radio frequency information, while you're doing your site survey, you're also going to need to pay attention about things in the environment that will help you to actually implement the wireless LAN infrastructure devices. Let's bring up another whiteboard and learn about this. Now, typically, the wireless access points will be connected to the wired network to allow the wireless users a connection to the wired network. So while we're performing a site survey, we're going to need to make notes on our floor plan or our blueprint, the locations of the data outlets, the locations of the actual data drops where we can plug in the wireless access point. So in addition to noting the actual location of the actual data drop, we should also estimate the amount of cable that's going to be required from the data drop to the location of the access point. And a very good method for measuring and estimating the amount of cable that's going to be required from the outlet to the access point is using the measuring wheel, which we spoke of in the miscellaneous section. So we can determine, hey, is that data drop too far from the optimal placement of the wireless access point? So again, we want to be a little under 100 meters from the outlet to the access point if we're using Cat5 cabling. However, all the data drops in the world aren't going to do us any good unless we can provide power to our wireless access point or our bridge. So while we're performing the site survey, we need to note the location of all the AC power outlets to make sure that there's one close enough to the location that we want to position the wireless access point or the bridge at. However, if there is not an AC power outlet close enough, we might be able to use an access point that has the power over Ethernet capability to provide power to it over the Cat5 cabling. But again, the cabling would have to be 100 meters or less in order to use power over Ethernet option. However, in some instances, you might just have to recommend to the client that they install an AC power outlet in order to place the wireless access point in the optimal location that meets the business goals and objectives for the wireless LAN. And lastly, if you're going to mount antennas outdoors, we need to take a couple things into consideration. Let's bring up a whiteboard and learn about that. Now, this situation is an excellent example where you could use your digital camera. We can take note and take pictures of the desired location for the antenna. Also, we can take pictures of any existing sources that we can mount the antenna on, such as existing towers. We can take pictures of potential obstructions, such as trees, lakes, rivers, buildings, etc. Also, we need to note any power sources that are outside as well, or the lack thereof, and then make accommodations for having a power supply near the outdoor antenna. Now, outdoor antennas, remember, have to be grounded and also have lightning arresters. So we need to take pictures and take note of potential locations where we can place a grounding rod and place lightning arresters. And with that, that brings us to the end of this video. Let's bring up a whiteboard and do a quick recap of what we've learned here. So we start off this video by learning about the equipment that we need to have in order to perform an effective site survey. We need to have a wireless access point. We need to have a wireless adapter. We need to have software or radio frequency utility software. We need to have either a laptop or a PDA, and a lot of miscellaneous equipment. And we learned about some of the issues surrounding that equipment that we have to be aware of for conducting an effective site survey. Also, in the actual conducting of the site survey, we need to gather some key information such as data rate, signal strength, noise, signal-to-noise ratio, throughput, and data rate boundaries, and any and all sources of radio frequency interference. Then we need to take all this information, put it in a report, which is going to be our site survey report. We're going to give that site survey report to the client and a finished copy to the installer of the wireless LAN, which again is going to serve as a map or as a guide for the installation of the wireless LAN. And with that, that brings us to the end. I hope that this video has been informative for you, and I'd like to thank you for viewing.